I welcome you all in this course of Introduction to Heat Transfer, a practical oriented approach. So today is lecture number 10, Radiation, Emissivity and Blackbody terms. So as far as before the 9 lecture we have conducted, so in this 9 lecture we are came across the types or modes of heat transfer and what are these modes and how they are play an important role in everyday life, also in engineering applications. So we have seen these in details. So right now the third mode of a heat transfer, that is a radiation, in that the terms were emissivity and blackbody, that we are going to see in this lecture in details. So let's start today's discussion. I am Amraraj Sawant, assistant professor from the Department of Mechanical Engineering. So introduction to thermal radiation. As we have discussed before, there are three modes of heat transfer. First is a conduction, second is a convection, and third is a radiation. So once again I will repeat for brushing up your concepts. So first is a conduction, which happens in solids due to the intermolecular or the molecular vibrations and the free electrons present between them. So that's why the heat transfer is going to take place in solids. So that type of heat transfer is what we call as a conduction. And in convection, the solid and the flow of fluids, means gases or some liquids are there, and due to the flowability and that flow properties, the heat transfer will take place from solid to that liquid, that is called as a convection. And this is a third mode of a heat transfer, which is a radiation, and it is caused due to the electromagnetic wave. So this is the third type or third mode of heat transfer, which is mainly caused due to the electromagnetic waves. So what is the thermal radiation heat transfer, that we are going to see in details. So introduction to thermal radiation. So radiation, as I have said, that emission of electromagnetic waves due to thermal motion. So just for beginning, just I have said that the radiation is that type of heat transfer which is caused due to the electromagnetic waves. But in actual practice, how these electromagnetic waves how they transfer the thermal motion. So basically the thermal radiation consists of electromagnetic waves, and that electromagnetic waves produces the oscillations of particles. So that oscillations of particles or electrical charge in that atoms and molecular level. So as the temperature increases, that oscillation between the charge between that atoms and molecules will going to increase. So the radiation is that kind of heat transfer where the temperature, surface temperature, if it is increased, then the total heat transfer will be 4 times increase, or it's increased by the 4th power. Okay, so that we are going to see in later slides. So it occurs without any medium. So this is the main difference between the other two heat transfer modes and this heat transfer mode. In conduction and convection, there must be some medium or fluid present to transfer the heat from one place to another. But in thermal radiation, there is no necessity to have any medium. So it can occur in a vacuum also, because these electromagnetic waves and the oscillation of that atoms and molecules between them, these can happen in a vacuum also. So this thermal radiation can transfer in a vacuum by the oscillation of the atoms or molecules in that electromagnetic waves. So the main form of heat transfer, we can say, as in example, the heat energy which is coming from sun to the earth is in the form of radiation. So the key feature of radiation. So electromagnetic waves are the main prominent factor that drives the thermal radiation. So the electromagnetic waves can travel with the speed of light. which is 3 into 10 raised to 8 meter per second. So they are quickly transferred, or they are travel with the speed of light. So there is a possibility that the heat transfer will going to takes place within a second from one place to another. That's why in before slide we have taken an example that the heat energy from sun is going to be transferred at earth surface, and that is in a radiation form, which is due to the electromagnetic waves. Okay, so it can occur in a vacuum, just I have before said. So no contact required. So in before modes like in conduction and convection, there must be some contact. Okay, in conduction, if the heat transfer will going to take place in, let's say, two solid metals, then they are must be in a contact. Let's take an example once again. So let's take these two solid blocks. Okay, so if the heat to be transferred from this solid block to this solid block, then they must be in a contact, as we have seen in a composite wall. So in a composite wall we have seen that the material property is different. That means its thermal conductivity is different for both these material, but heat transfer can only be achieved or can only be possible when they are in a contact. Okay, and as far as convection heat transfer concerned, for this hot metal plate, if the air is flowing over this hot metal plate, the air must be in a contact with this hot metal plate to transfer the heat, as far as the convection heat transfer mode is concerned. But in radiation, for transferring the heat, there is no necessity to be both surface to be in a contact with each other with some distance. Likewise, I have said in a before slide that sun, the heat from the sun we can get at earth surface, and as you know that both are not in a contact. So how it is possible? Because of electromagnetic waves can travel with the speed of light, and while traveling, the in between whatever the electromagnetic waves are there, so at a molecular level they are oscillates between the atoms and molecules, and due to which the heat is transferred within a second. Okay, so what is the electromagnetic nature? So it is produced by oscillation of charges in the atoms or the molecule. Likewise, I have said before. So as the temperature increases, more radiation. What is mean to say here? When the temperature of any surface, let's consider this as a sun surface. Okay, as the temperature of this sun surface, okay, is increases, the oscillation or oscillation charge in that atom or a molecule level will increase, and because of oscillation of that charge on that atom will increase, that's why the radiation energy will also increase, or radiation heat transfer will also increase. So it is directly proportional to the surface temperature of that object. So the electromagnetic nature of these which is mainly causes thermal radiation or thermal heat transfer. So that spectrum is come under infrared waves, visible light, and UV rays. So emissive power of a surface. What is mean by that? So all matters above 0 Kelvin emits radiation, and that is validated by some experiments. So all matters, any substance, you can take any substance. You can take your home appliances or your mobile or your laptop, any appliances or any object in this world above 0 Kelvin, above 0 Kelvin temperature always emits some kind of radiations. Okay, even you can check your mobile radiations by some number, I don't remember that, but your mobile radiations, if they are let's say with is above a certain level, then it is dangerous to your health. So it is mandatory by telecom ministry that the mobile radiation should be in a certain range. Okay, so you can check that also. So depending upon the temperature and the surface properties. So emissive power means how much energy that object is going to emit. That is the emissive power. And that emissive power, first of all, every object can emit radiation energy when it is above 0 Kelvin, when its temperature is above 0 Kelvin. And second of all, the emissive power is purely depend upon temperature and surface properties. Likewise, I have said before, the radiation heat transfer is mainly because when the temperature rises, then the electromagnetic or in electromagnetic waves, the oscillation charge in atom and molecule will rises, and that's why the heat transfer will be more. So here the temperature means emissive power is depend on temperature and the surface property, how the surface geometry and its design is there. So that's why higher the temperature, higher the radiation. Likewise, I just said before, when higher is the temperature, then higher oscillation of charge in that atoms and molecule in electromagnetic waves, and that's why higher chances of radiation means higher chances of heat transfer in the radiation mode. Okay, so here is some basic comparison between the three modes of heat transfer. First is a conduction, second is a convection, and third is a radiation. So here we compare radiation with respect to conduction and convection. So radiation, first basic thing is that radiation does not need any medium to transfer. Why? Because once again the electromagnetic waves are traveling with the speed of light, and in that electromagnetic waves the charge in the atoms and the molecules are oscillating, okay, with their central position, and due to the oscillation of that charge, the heat will be get transferred, and due to high speed or travel in a high speed as compared to the speed of light, so the heat energy can travel within a second, or heat energy can travel very fast. So that's why the radiation doesn't need any medium. So the heat transfer is possible in a space because it doesn't need any medium. So example, sunlight reaching at earth, just like we seen before. So surface properties affecting the radiation. In before slide we have seen that the emissive power means what? Any surface which is having radiation, which is ability to radiate some energy, that energy, how it is radiating, that power is known as emissive. So how much energy that surface is going to emit, that is called as a emissive power. So which is the emissive power is mainly dependent on the temperature and surface properties. Okay, so black surfaces, right now here we are going to see that these terms, the black body and emissivity, gray body, like that. So black surfaces are the good absorber and emitters. So what is mean by good absorber and emitters? Let's say this is a black object. So this black object is going to transfer the heat from this black object to surrounding. Okay, let's say this black object is at 100 degrees Celsius, and this black object is going to transfer the heat from its body to the surrounding. So what is the black surface? Black surface definition says that it is a good absorber and emitter. Emitter means this energy is going to emit from this surface, and absorber means this surface will going to absorb the heat from the surrounding. Okay, vice versa. So in a first example, likewise I have said, if this black body or black surface is at 100 degrees Celsius and surrounding as at a 30 degrees Celsius, then this surface will act as a good emitter. And in second case, for absorber, let's say this surrounding will at 100 degrees Celsius and this black body at 10 degrees Celsius, then the heat is going to transfer from 100 degrees Celsius to 10 degrees Celsius, then this surface will act as a good absorber. So what is mean by the black surfaces? That surfaces are good emitter also and absorber also. So they can emit the energy and can absorb the energy. Just keep in mind that heat will always going to transfer from higher temperature to the lower temperature by second law of thermodynamics. And if you apply this thing anywhere, so you can easily crack how the things are going to be. Okay, so white and shiny surface. So white and shiny surface reflect the radiation and it is poor emitter. So again we can take this as an example. Let's think this is a white surface. If this is a white surface, then if it can reflect the energy, that means the energy can reach this object but can't be absorbed, it is going to be reflected. So for the white or the shiny surface, the surface property is like that, it is going to reflect the energy, it is not going to emit, okay, or it is not going to absorb. Some kind of energy is going to absorb, but it will not take total energy within it. Okay, so the white surface property is that it is a good reflector. Reflector means the energy is going to be just reflected, and it is not a good emitter also. So polished surface or polished metals surfaces are good reflection of infrared. So it is used as in shields. Okay, so importance of this heat exchange or heat transfer by the virtue of radiation mode. So how it is important in engineering, that we are going to see. So in heat exchanger, the heat is going to exchange by the convection mode also, conduction mode also. But in some kind of like in a you can take an example of a car radiator. So in radiator, the heat will going to transfer in both, means by applying all three modes, not only in a conduction and convection. Some kind or some part of the heat is going to be reflected or transferred by radiation also. So for designing or for calculating how much energy or how much heat transfer is going to be transferred from one object to another is going to calculated by this radiation. So spacecraft design. So this is one of the important aspect or important application of engineering as per as radiation heat transfer is concerned. So in a spacecraft design, the spacecraft is going to travel from Earth's atmosphere to vacuum, that is in a space, and if it is going to return to Earth's atmosphere, then it will have to experience more friction and more resistance, and due to which their outer surface of the spacecraft is going to treat like a you are going to sit in an oven. So that outer material should be such that the heat transfer should be minimum, so that the internal components of that spacecraft will not damage until unless the spacecraft will be returned to Earth's surface. So that is one of the kind of application, and it is important application of radiation heat transfer and how to minimize that. So that we will going to see in lecture number 13. So this is the most important application of radiation heat transfer in building insulation also. So and in electronics cooling system also. In actual life, all the three modes of heat transfer will act simultaneously. Let's say this is a one object, and or building insulation object or any electronic cooling object or any electronic device component, then it will have a conduction within it. Also, if any air is flowing over it, then it will have convection also. And due to this surface nature, if it is a black body or white or shiny body or a polished metal, then it will go, somewhere it will going to emit the radiation, or it will going to absorb the radiation. So in actual practices, all the three modes are going to act simultaneously on every object. Okay, so what is mean by black body? Likewise, we have just before seen that the black body is a perfect absorber of energy or heat which is in a form of radiation. So absorb all incident radiation. Likewise, here you can see that. So here the black body is absorbing all the radiations, so it is perfect absorber and it is perfect emitter. It can emits maximum radiation at that given temperature. So it is used as a reference or a standard in a radiation study. So black body is not a practical body, it is an imaginary thing that will emit all radiation and that will absorb all radiation. In actual practices, the body or any object having the property that it will emit certain radiation, and certain radiation or certain heat will going to be retained in that object. Okay, but for engineering perspective, we have consider or idealize the thing that perfect absorber means all energy or all energy or all heat energy in the form of radiation is going to be absorbed and all heat energy is going to be emitted, that is a perfect emitter. So the black body, the term black body is that the black body is a perfect emitter and absorber also, but it is not in a real sense. It is only the standards for purpose of radiation studies. So what is emissivity? So the emissivity term here, epsilon, is equal to actual emissive power of object upon emissive power of black body. So first of all, I have just elaborated you that what is emissive power. Emissive power means for any object, the object which is having some kind of energy within it, so how much energy is transferred, or the what is the ability of this object to transfer the energy in the form of radiation is called emissive power of this object. Okay, so how much energy is going to transfer in the form of radiation is emissive power. So emissive power of any object is equal to E upon emissive power of a black body is EB. So emissivity is equal to ratio of emissive power of any object to the emissive power of black body. So it's ratio of actual emissive power of black body, and it ranges from this epsilon value. This epsilon value is ranges from 0 to 1. If its value is 1, then it is called as a black body. Why it is so? So let's take an example. If let's say for this body, okay, its emissive power is 10 watt. It's 10 watt. And for ideal study of radiation, we consider this body, and this body is also having the emissive power of 10 watt. Okay, so if this body, if we consider this body as a black body for our understanding, okay, but in actual case this object will also having the temperature, will also having the heat transfer rate or emissive power of 10 watt similar, then this body will emit the power same like as this black body. So this object, real object, can be treated as black body. When it is so, when this ratio 10 watt, when this ratio will be equal to 1. So when this ratio of object, emissive power of object to the emissive power of black body, when it is equal to 1, then this object can be treated as a black body. But in actual practices, it is not a possible thing. We are considering a black body for standard for studies or for analysis of the radiation problems. Okay, and if this value is 0, if this value is 0, if this emissivity power is 0, then that body is a perfect reflector. Why? Because the emissivity is a reciprocal of reflection. The physical meaning of emissivity. So if high emissivity is there, then efficient radiator or cooling. So for high emissivity, that means the emissive power of this object is moreover equal to the emissive power of a black body. Likewise, I have given this example. So if you consider this as a black body, then if the emissivity epsilon of this body, if it is higher side, then it will be certainly act as a black body. Okay, that means its emissive power is more. It can emit the heat energy in form of radiation in more capacity. Okay, and similarly vice versa, if its emissivity is lower, then it can retain heat. It will not going to emit the heat will going to retain within it. Okay, so it is used as an insulation. If for low emissivity, it can retain heat, and that means it will not going to transfer the heat from this body to surrounding, so it can used as a insulation. So examples, simple example, our human skin is having emissivity of 0.98, so very near to the 1. So that's why our human skin we can treat approximately to as a black body. Okay, and polished metal surface, you can see here, polished metal surface having emissivity approximately 0.05, so it can't emit the heat. The heat will be going to reflect. Okay, so gray body and real applications. So what is mean by gray body? Just now we have seen that what is a black body. So right now we are going to see what is a gray body. So these kind of definitions are there for analysis of the how the radiation heat transfer will takes place. So gray body is that having constant emissivity for all wavelengths. Means what? Let's take an example of a composite wall. If that composite wall, if we consider as a one composite wall as a one object, then it is a possibility that it can emit the radiation, okay, in various wavelengths. But gray body here the definition as a gray body, it is having the constant emissivity for all the wavelengths. So if all the types of rays like infrared and UVs and some other waves, so that electromagnetic waves having different wavelength, for any wavelength the emissivity, that means ability to emit the power, is going to same, or we are considering it is constant. Okay, so what are the, and this body is general life example, or we are just doing the realistic approach to the black body. The black body is an imaginary thing. Actually, in actual practice, there is no object which is a perfect emitter and perfect absorber. There are some heat is going to retain in some objects. Okay, so gray body is just a real life implication of that black body, that overall the emissivity means the power, or the power to emit the heat for any wavelength is going to be constant. We are taking it as a constant. So what are the real life application of this radiation? So thermal imaging cameras. So just before, I think so, 4 to 5 months, our Indian Army had surgical strike over the POK. So where there the thermal imaging cameras were used, and how these thermal imaging cameras are going to use is the best example of radiation heat transfer. So it will measure the IR radiation and to detect the temperature. So likewise, I have said, if any object above 0 Kelvin will emit the radiations. Okay, so any object, human body also, or you can take any object or appliances or any stationary thing or moving thing above 0 Kelvin, it will going to reflect, or it will going to emit some kind of radiation energy, and that kind of radiation energy in infrared waves we are going to detect with the use of thermal imaging camera. So that's why in the night also we can see the human body which is emitting the heat. Okay, so infrared cooking and the heaters, everyone one of you know that the ovens, where the bakery products are produced. So there in ovens, the high emissive element radiate the heat to cook or the heat the object. The bakery products where the heating or cooking takes place, where the oven, the high emissive element is used to heat that cooking or heat that object. So heat shield in a spacecraft. Likewise, I have said that when any spacecraft is coming from the space to Earth's atmosphere, then there will be the more resistance, and due to this atmospheric resistance, the high heat will be going to transfer from atmosphere to that spacecraft, and that is a more dangerous thing over there. So because of heating up the spacecraft outer structure, if internal components if they are heated up, and so that's why in more cases the failure happens. So that's why the heat shield in the spacecraft is provided not to transmit the heat inside the components of the spacecraft. So low emissive coating reduces radiant heat absorption. So low emissive material are provided to not to transfer the heat from atmosphere to that spacecraft. So building insulation, likewise I have just elaborated you. Use of low emissive glass to reduce heat loss or gain. I think so you generally seen that multi-story buildings in Mumbai or some metropolitan cities. So over there you have seen that the total building, multi-story building, is covered with some blue colored, or that glass is there from top floor to the bottom floor. So how the heat will be managed there? So that glass is a thermally radiated or thermally insulated glass. That's why the heat energy which is coming from sun and outside surrounding will not going to transfer within that building. And if that heat is not going to transfer within that building, okay, or transferred from surrounding to that building, that the cooling load, that means for use of the air conditioning, will be minimized, and it will be the energy efficient building. So that's why the material or the glass is used which is a thermally coated. So radiator design, high emissive paint is used to radiate the high efficiency. So in radiators, where in IC engine also, so high emissive paints are used to emit the power, because in radiator we need more heat to be transferred. In solar panels, the solar panels, you know that how solar panel works. The solar energy will strike the panels, and due to the PV cells or due to the heating, the PV junction will get activated, and due to which the electricity or in the form of electricity energy we can get it. So the emissivity there should be more, because if more emissivity, then the temperature and efficiency will be more, and if the temperature and efficiency will be more, the more electricity we can generate. So that's why in rainy days or in rainy season we can get lower output from our solar panel. That's because the solar energy that is transferring from sun to the earth surface in the form of electromagnetic waves that are going to strike on your solar panel will be minimized, okay, will be minimum, and that minimum striking with a minimum temperature will have minimum efficiency, and that's why we get minimum output in a rainy season with the solar panel. But right now some research is also going there to compensate this effect. So summary and the key points of this lecture is: radiation is a heat transfer by electromagnetic waves, and how it is. In electromagnetic waves, the charge on the atom or a molecule will oscillate, and that oscillation will have speed of light, and so that the heat will transfer quickly, okay, and it doesn't require any medium. So the black body is ideal absorber and emitter, and it is not a real object. Emissivity indicates how close to the black body. Emissivity is a ratio of emissive power of any object to the emissive power of a black body. So engineering applications everywhere we have just seen. So thank you very much. So I conclude this lecture here. You will have 20 multiple choice questions assignment of this lecture. Also, I will provide this lecture notes in the discussion forum box, and you feel free to ask me anything about this lecture in discussion forum. Thank you very much.